Now the next three say that you're finding the complex solutions, which again tells me I'm probably going to use the quadratic formula, but this time I may or may not end up with imaginary numbers. Most of the time you will, but sometimes they throw in one that's just a real number, because technically that's a real number plus a 0i, which is a complex number. So when it says to find the complex solutions, again, we're going to use our quadratic formula. And so we're going to plug our numbers in and go ahead and solve. So if I have x squared minus 5x plus 7, a is going to be equal to 1, b is going to be equal to negative 5, c is going to be equal to 7. So I'm going to have minus my negative 5 minus the b value of negative 5 plus or minus the square root of negative 5 squared minus 4 times the a value of 1 times the c value of 7 all over 2 times the a value. So since I have minus a negative, it becomes positive 5 plus or minus here. This is going to give me 25. This is going to give me minus 28. So I have the square root of negative 3 over 2. So this has a negative in it. I have to take the I out of there. So I'm going to have 5 halves plus or minus the square root of 3 over 2, and the I is going to go behind there. Notice again on that square root, the square root is over the 2, or over just the 3, not over the 2. The 2 is a nice whole number 2. And so again, hit the fraction button first, type in the square root of 3 over 2, and then the I goes behind your fraction. Again, on Alex, they're going to make you put in 2 separate answers. So 5 halves plus the square root of 3 over 2i, and then 5 halves minus the square root of 3 over 2i. Now these ones don't say that you have to put them in standard form. So if you did put them at one big fraction, it's still going to work. But this is what it would look like in standard form. So number 11, again, I'm going to use my quadratic formula. This time, a is going to equal 8, b is going to equal 1, because that's a 1x, and c is going to equal 2. So I'm going to have minus the 1 plus or minus the square root of 1 squared minus 4 times the a value, which is 8, and the c value, which is 2, over 2 times the a value. So this is going to be negative 1 plus or minus the square root of, this would be 1, and that's going to be minus 64, so I'm going to have a negative 63. So simplifying this, 63 is 9 times 7, I'm going to have 3, or I'm going to put it this way, 3 square root of 7i then, right? And so I'm going to have negative 1/16 plus 3 square root of 7 over 16i, and 1/16 minus 3 square root of 7 over 16i, if I put them in standard form. Number 12, simplifying my quadratic expression again. A is going to equal 1, B is going to equal 5, and C is going to equal negative 5. So negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 5 over 2 times 1. So negative 5 plus or minus. This would be 25. This would be plus 20, so that'd give me the square root of 45 over 2. So on this one, we don't have the imaginary number part, but we can simplify this into 9 times 5, which is 3 squared root of 5. So I'm going to have negative 5 plus 3 squared root of 5 over 2, and then negative 5 minus 3 squared root of 5 over 2. Again, they're going to make you put it in 2 separate answers. There's no plus or minus, but that one doesn't have an imaginary number part, so I'm just going to put my real number answer. You'll get both kinds, most of the time the imaginary ones.